Hello, this is Mrs. Rutchling. Welcome to Chapter 8, Molar Volume. So in addition to mole ratios, where we're going from one substance to another, and molar mass, where we're going from grams to moles, we can also use molar volume for a gas. At standard temperature and pressure, which is what we'll be working at in this chapter, and it is 1 atm, which is a pressure unit, and 0 degrees Celsius. At STP, there's 22.4 liters of any gas per 1 mole. Because it is an equality, we can put it as a conversion fraction. We can have the liters on top or we can have it on the bottom, depending on what we need to cancel out. Because the gas particles are so small, their volume is the same for 1 mole, 22.4 liters. Their mass can change. For helium, there is 4.003 grams per 1 mole. For nitrogen, 28.013 grams per 1 mole. But the volume is the same, 22.4 liters. And that is true for every gas that we will work with. What is the volume at STP of 4 grams? We know that 22.4 liters is the volume for every 1 mole of gas. But we don't have moles, we have grams. So the first order of business is to go to the periodic table and use the molar mass. When we use the molar mass, we can change grams of methane to moles of methane. Remember, grams per 1 mole from the periodic table. But it doesn't ask for moles, it asks for volume. So I can use my 22.4 liters per 1 mole as a conversion factor and change it to liters. Pause the video and try problem B. The problem starts with liters of gas. To change to grams, I know I need to use the molar mass, which means I need moles. So again, the 22.4 liters per 1 mole is used. This time I have liters, so the 22.4 liters goes on the bottom. I have 1 mole of helium, and using the molar mass from the periodic table, I have 4 grams of helium per every 1 mole of helium. When I do the calculations, I end up with 1.4 grams helium. Let's try a more complex problem, going back to our mole ratios. I have 1.1 gram of hydrogen peroxide. Hydrogen peroxide is sold in brown bottles. That's because light causes it to decompose into water, gas, and oxygen. The question asks for volume of oxygen at STP. That means I need to go to oxygen. I'm going to use my mole ratio, but then I need to know how many liters. It says that there's a flask with a volume of 2.5 liters. That's really extra information. I start off with 1.1 grams of hydrogen peroxide, but I need to go to oxygen, so I know that the molar ratio is going to come into play. That means I have to go from grams of hydrogen peroxide. Then I'm going to have to go use my mole ratio to go from hydrogen peroxide to water. Lastly, I need the volume of gas at STP. That means I'm going to change to liters. The problem starts with grams of hydrogen peroxide. Using the molar mass from the periodic table, I have 34.02 grams per 1 mole of hydrogen peroxide. Then I need to go to oxygen, so I'm going to use the mole ratio. That allows me to cancel out moles of hydrogen peroxide and end up with moles of oxygen. The problem asks for volume of oxygen at STP. That means I can use the 22.4 liters per 1 mole and end up with liters of oxygen. This problem has 2 parts because it tells us we have grams of glucose and we want to end up with liters of water. That means we need a balanced equation and we don't have one. That is the first step to write the equation of combustion of glucose. Pause the video and try to write that equation. When we write combustion, we know that we have a hydrocarbon and all fire needs oxygen. Our products are always the same, carbon dioxide and water. We know that the state is gas because it says how many liters of water vapor. Doesn't really tell us the rest of those, so I wouldn't expect you to put those in. There's 1.06 grams of glucose, and I need to have water. So that means I need to go and use my mole ratio. And then I need to know how many liters at STP. Starting with grams, I know I need to get to moles. So I go to the periodic table and find out that glucose molar mass is 180.16 grams per 1 mole of glucose. Now I can cancel out the grams and I have moles of glucose. To get to water vapor, I have to use the molar ratio from the balanced equation. Using that gives a value of moles of water. It's asking for liters and it says it's at STP, so the relationship of 22.4 liters per every mole can be used. This is a summary of everything we've learned so far about stoichiometry. We have a given value of G, and we want something that's different species. That means we have to use the mole ratio. We can start off with atoms or molecules, particles, and use Avogadro's number. We would have moles. We could use the mole ratio, and then we can end up with particles, mass, or volume. You have to read the question carefully to decide what conversion factors you will use.